Hi, welcome back. In this lesson, we are going to use three cases to understand left tail and right tail test and two tail test. We are also going to understand the decision rules to accept a null hypothesis or to reject a null hypothesis. There are three common types of hypothesis testing. Test of hypothesis about population mean, test of hypothesis about population proportions, and test of hypothesis about population variance. Hypothesis testing for population mean with known variance. Here we are going to discuss the population or we are going to discuss hypothesis testing for the population mean when the population variance is known. Since the hypothesis is carried out with just one example, this test is also known as one sample Z test. So one tail test of means. So this is a case that we are going to discuss here. Okay, an agency based out of Bangalore claimed that the average monthly disposable income of families living in Bangalore is greater than 4,200. Okay, this is a claim made by one agency of Bangalore. Okay, with a standard deviation of INR, the survey has been done. The standard deviation is found to be 3,200. From a random sample of 40,000, this is the N. N means this is the sample size, families. Average disposable income was uh, estimated as 4,250. So what is the claim? The claim is made that average monthly disposable income of families living in Bangalore is greater than 4,200. But the sample it is found that 4,250. Assume that the population standard deviation is 3,200. Conduct an appropriate hypothesis test as alpha. This is 5% level of significance to check the validity of the claim by the agency. Okay. So these are the values that we have derived. So this is the claim we have got. The claim is that is called mu equal to 4,200. Then standard deviation it has been found. This is population standard deviation is found to be sigma equal to 3,200. Then this is the sample size. Sample size is for 40,000. This is the 40,000. Then this is the sample mean. This is the sample mean that we have found 4,250. Okay. Then we have been given another value that is a 5% level of significance that is called alpha equal to 5,000, alpha equal to 0.05 or 5%. Okay. So null hypothesis and alternative hypothesis can be stated as this. This is called null hypothesis. This is null hypothesis. This is alternative hypothesis. Null hypothesis mu is less than equal to 4,200 and alternative hypothesis is equal to H1 mu is greater than 4,200. Let us understand this. Okay, what is the claim? The claim is this is greater than. When a claim is made, because it is questioning one existing theory. Let us recall our past lessons on hypothesis testing. That means we discussed that when this alternative hypothesis question one existing theory, what could be the existing theory? Existing theory is always against the claim. Okay, so therefore the claim is existing theory is less than or equal to, and here it is the claim is greater than. Okay, claim is mu is greater than this. Always try to understand this when we frame hypothesis. The rejection or tail has to be recognized in the direction of the alternative hypothesis. What is the direction of the alternative hypothesis? One tail test is always one directional, whether it has to be right directions or it has to be in left direction. So you see this is in right directions, therefore it has to be a right tail test. So this is the formula we have seen in the previous lessons. Z starts equal to x bar minus mu, then this is the sigma divided by root n. So we have just filled the value here. This is x bar equal to 4250. We have written all these things here. Then mu equal to 4200 divided by, this is the sigma value, 3200 divided by root n is 40,000, okay, equal to 3.125. Let us make the distributions, z distributions, okay. So alpha value is 5,000, 0.05, okay, this one is 5%, this is the rejection region, this is the rejection region, okay. That means we are here, what we are doing, we are comparing the z critical with the z starts, simple. What is the z critical value for this? For 5% alpha, this is the at the right side, therefore plus 1.645 is the z critical value, okay. What is the calculated value? Calculated value is 3.125. This is the 3.125. So therefore it falls here. That means it falls in the rejection area. So always let us remember, we accept or we fail to we don't accept H0. Okay, we have to make a conclusion on H0. Since our Z statistics, that is 3.125, falls in rejection region, therefore we fail to accept or we reject the null hypothesis. This has to be our conclusions. Conclusion, you see, suppose we have to write in our research report. So we have to write that we reject H0 as Z statistics or Z calculated, we can call it also Z calculated, 3.125 is greater than the Z critical. This is the greater value, okay, and falls in the rejection region. So this is how we can write report in our research thesis or research papers, okay. So let us discuss another case. So there is another case we are going to discuss, a left tail case test. So a passport office claims that passport applications are processed within 30 days of submitting application. Let us understand here once again, because this is very important to build the null and alternative hypothesis. What is the claim? The claim is within 30 days of submitting. So claim is less than 30 days. Let us remember here, okay. And the application form and all necessary documents. The table that you see shows the processing time of 40 passport applicants. So what is the n equal to 40. The population standard deviation of the processing time is 12.5 days. This is given, and we have to conduct one appropriate hypothesis test at the significant level 0.05 to verify the claim made by the passport office, okay. So this is the data that we have been given. This is the 40 applicants data. The first data, it is given that 40 days, it took 16 days to process the passport, and then 34, then 28, then 21. So what is missing here? One value that is missing, that is called x bar. Okay, x bar means sample means. So how to calculate sample means? What we have to do? We have to sum up all these values, that is 40 values that are given in the tables, divided 40. So we will get the sample. Okay. So let us see it given that this is given. This is 30 days is given. This is mu equal to 30 days. It is given. Then alpha it is population standard deviation is given. This is called this is 12.5. Then 40 is the n number of applications. Then x bar we have calculated. All these we have summed up. All these values in the table we have summed up, and we have divided by 40. Then we got this value. Okay, this is x bar. Then this is alpha, that is called that 0.05. Okay. So first we have to see, we have to develop this null and alternative hypothesis. This is called null. Null is represented by h and sub 0, and alternative is 1 and sub 1. Okay. So these are the null and alternative hypothesis. So this is the theory that talks about that this is mu is equal to or greater than 30. That is being questioned, therefore it is within 30 days. So that means here the tail is in the direction of the left. You see, this is at the left direction. Therefore it is a left tail test. Okay. So what we'll do here, z, we will calculate the z value, z equal to x bar minus mu, then divided by sigma, that is called population standard deviation, divided by root n. So we have just filled up the value, taking values from here. These are the values we have taken and we have filled here. Okay, so we have got this value. This is the value, z starts value, we have got this. Okay, so let us look into the distribution. This is the z distribution, middle it is 0. Okay, so left side is minus, we have got minus 1.49. so z critical for this, it is 5% critical. But remember the right tail test that we are discussing in the previous one, we are discussing that it was at the right side, so therefore the value was, it is plus 1.645. since it is at the left side, the value has to be minus 1.645. so you see, we have to compare this critical value with the calculated value, calculated or statistics, that statistics that we can calculate. So this is minus 1.49. You can see this is here in the acceptance region, because it is now in the left side, it is greater than the critical value. Therefore what we do, we have to conclude, we fail to reject H0, because it is, why we are rejecting, we are accepting here H0, because it falls in the acceptance region. These are the acceptance regions. Okay, so as z statistics or z calculated value minus 1.4925 is less than the z critical, okay, and falls in the acceptance region. Okay, so then we have to see another, like total test of means. Total test means, we, according to the company, we are going to discuss another case. So we have seen one tail test, another we have seen also one two tail test. So we have seen one tail one left tail test, one right tail test. Now we are going to see the two tail test of means. According to a company, IQ research, the average IQ of an Indian is 82, derived based on a research carried out by Professor Richard Lynch, a British professor of psychology, using data collected from 2002 to 2006. That means the professor has conducted one research on the IQ level of Indians during this period 2002 and 2006, and he has found that average IQ of an Indian is, this is 82. The population standard deviation is found to be 11.03 based on a sample. This is the sigma that we can talk about. This is the best of sample. This is n equal to 100 based on a sample of 100 people from India. The sample IQ was estimated as 84. Okay, x bar is 84. Conduct an appropriate hypothesis test at 5% level of significance. That means this is 0.05 level of significance to validate the claim of IQ research that the average IQ of an Indian is 82. So this is given. So this is population mean that we have got it. Population mean that we have got it. It is 82. We have got it 82. Then sigma we have got it. It is called. We have got sigma here. This is sigma, population standard deviations. Then this is the sample. This is the x bar. This is the number of sample. This is the sample mean. Okay. This is the alpha. So let us develop this null and hypothesis. So since it is here, it is not telling about anything or something is greater than or something is less than. It is telling is equal to is. Therefore, we'll accept. Sorry, this has to be 82. Actually, this has to be sorry. This has to be 82. This has to be 82. Okay, this has to be 82. I have not read. This has to be 82. Okay. So here, because mu equal to 82, it is okay. So Null and alternative hypothesis can be built like this. So it is equal to and not equal to. That means we will accept it if it is equal to 82. If we are not going to accept if it is not equal. That means if it is greater than 82 and less than equal to the 82, that we are not going to accept. Okay. So what we are going to understand. So this is what we have done. This is the formula for this. This is the formula for this. We have just filled up x bar minus mu divided by sigma by root n. So this is the value. Just we have put the value and we have got this is the output that we have got. That means Z calculator or Z statistics is 1.81. So this is the distribution that we have found. Okay. This is the distribution that we have found. This is the cutoff. Let us remember this critical value that we are taking, that divide the total distribution into two parts. One is rejection region, another is acceptance region. So this is the rejection regions that we are talking of. This is the acceptance region, we can see. Okay, so these are the cutoff. So here this is the critical value 1.96. This is the plus sides, this is the plus side, this is the minus sides, you can see. So because 5%, when we have taken 5% significant level, this 5% has been divided into 2. Therefore alpha by 2, the 5% by 2, the result becomes 0.025. 0.025 Z distribution's critical value will become 1.96. Okay. So calculated value is 1.81. It is at the right side, positive value. Okay, and it falls in the acceptance region. Therefore, what we are going to do, we accept the H0 here. Therefore, we conclude that we fail to reject. That means we accept H0 as Z statistics or calculated this value is less than the Z critical and falls in the acceptance region. It is very simple. So this is the decision criteria that we have to see. See, this is the three tails that this is left tail test we discussed. This is right tail test. Rejection is taking place at the right side. It is in case rejection can take place at the both sides. Okay, this is alpha by 2. Okay, this is alpha 0.05. This is alpha 0.05. This is alpha by 2. That is 0.025. That we are going to see. Okay, we have seen all these things. Okay, this is the decision rules. Decision rules, we can see Z statistics. This is Z statistics less than left tail. In case of left tail, Z statistics less than critical that score, critical value, we reject H0. Okay, we can see all these things when we make certain kind of decisions on accepting or rejecting. We have to plot it actually. Okay, we have to make it and we have to see that whether it falls in the rejection region and that acceptance region. Similarly, this is if Z statistics in case of a left tail test, it is greater than or equal to critical value, we have to retain H0, means null hypothesis. In case of right tail test, it is Z statistics greater than critical value, we have to reject H0. In case of right tail test, once again Z statistics less than or equal to critical value, we have to return H0. So in case of two tail test, so rejection will take place at the both the sides. Okay, with alpha divided by 2 as we have to see that is the level of significance. So Z statistics greater than critical value, we have to reject H0, and Z statistics less than equal to critical value, we have to retain H0. So there is another which we have not seen. One is p value. So alpha value, what is the alpha value here? 0.05. 0.05 is the alpha value. Okay, if p value is less than, we have to calculate this p value, we have not seen. If it is less than 0.05, that means there is a significant difference between your sample mean and hypothesized population means. Therefore, what we are going to do, we are going to reject the null hypothesis and reverse is true in case. Okay, don't reject null hypothesis if p value is greater than or equal to alpha value. So these are the important that criteria that we must remember. Then there are some of the quick steps. Let me put here. Like first of all, quick steps in decision. The hypothesis testing. We need to develop alternative hypothesis. First, we have to develop, in case of hypothesis testing, we have to read the problem and we have to develop H0 and H1. Okay. Then we have to specify the level of significance that is given, whether it is 5% or 1% or 10%. Then we have to compute the value of test statistics. Once it is test statistics is computed, so what we need to do, there are two ways that we have to look into, that how to, whether to accept the null hypothesis or not accept the whole hypothesis. One is p value method, another is critical value method. In case of p value method, if p value is less than the alpha value, that is 0.05, take for example, that means there is a significant difference between the population mean and the hypothesis population means and sample means. Therefore, we reject the null hypothesis. Okay. In case of critical value, we have to find out once again the whether this critical value that divides completely the entire distribution into two parts. One is acceptance region, another is the rejection regions. Whether this test statistics falls in acceptance region. If it falls in acceptance region, we accept null hypothesis, else we reject null hypothesis. That's for the lesson. See you in the next one.